Okay, so this is the worksheet on using properties of logarithms to condense the log expression. And then whenever possible, it says write the expression as a single logarithm whose coefficient is 1. And where possible, evaluate the log expressions. And without using a calculator. Okay, so there are three properties you're going to use here dealing with logarithms. So let's kind of remind ourselves what those properties are. So three properties of logarithms that you're going to use here. The first one is called the product rule. And so remember, the product rule says this: if you have the log of a product, m times n, with some base b, then you can rewrite this as a sum of the logs of each of those factors. So it'll be the log of m base b plus the log of n base b. The quotient rule, so think division, quotient rule, says if you have the log of a quotient, m divided by n, with some base b, then I can write this log of a quotient as the difference of the two logs. So it'll be the log of the numerator, base b, minus the log of the denominator, base b. And then the other thing you're going to use will be the power rule. And so the power rule says if you have the log of, let me write this as x to the m power base b, then you can take that exponent and raise and write as a product. So this becomes m times the log of x base b. Okay? All right. Now, these problems here, notice you have two logarithms. And in some cases, you have three. So whenever you have two or more logarithms, what you want to do to condense it is to write it as a single logarithm. So basically, you're going backwards here. So you see how we expanded? So going from here to here, we expanded. We went from one logarithm to two, if you look at the product and quotient rule. To condense means if you have two or more logarithms, as long as they have the same base, remember they have to have the same base, then you can write as a single logarithm. And then when we write as a single logarithm, we want to make sure we have that coefficient here to be 1. Okay, we want this to be a 1. Okay? All right. Now, let's look at number 1. Number 1, we have the log of 50 plus log of 20. So I want to, first of all, write this as a single logarithm. Notice the bases are the same. The base is 10. So this is a common logarithm. And so according to the, remember that you had dealing with sum here. So according to the product rule, I can write this as the log of the product of the arguments. So it becomes a log of 50 times 20, okay? And then 50 times 20 becomes, so it'll be the log of 1,000, right? And then notice the problem says, where possible, evaluate the log expression, and you really want to do this without a calculator. So all of you should at this point recognize that the log of 1,000 you can evaluate. So remember the base is 10, right? So you're going to say 10 to what power is 1,000? Well, hopefully you said the answer is 3. So remember what we did. We said log of 1,000. Remember how we did this in a previous section. So we changed this log equation to an exponential. So this is 10. So 10 to what power is 1,000? And so the answer is 3. So 3 goes in the exponent. Okay? All right. So the answer to number 1 is 3. Okay, number 2, you have the log of x plus 3 times the log of y. Okay, now you have to remember this situation. In order to condense, in order to write this sum or this difference as one logarithm, those coefficients have to be 1. Okay? Notice this coefficient is a 1, 1 times the log of x, and this says 3 times the log of y, right? So that coefficient here is not a 1, it's a 3. If I'm going to write this as a single logarithm, those coefficients have to be 1s. This one's not. So I need to remove that coefficient. Well, remember, that's where that power rule comes in. So if you have m times the log of x base b, you can always take that coefficient and write it as an exponent. So you're going backwards here. So meaning this right here becomes the log of x plus the log of y cubed. Okay? And always think about this. If you were to use the power rule and take that 3 and write as a product, then you would get this back. Now I can use, see, this is a sum of 2 logs, same base. Now I can use the product rule. So it's write as a single logarithm, okay? 1 log, 1 log. And so my argument then is going to be the product of these two arguments. So it'll be x times y cubed. And there's your answer. Okay? All right, number 3. You have 7 times the log of x base b plus 3 times the log of y base b. All right? So notice I cannot use the product rule first, because this coefficient is 7, it's not a 1. This coefficient is a 3, it's not a 1. So I got to get rid of the 7. So I got to take this coefficient and write as an exponent. I got to take this coefficient and write as an exponent. So using the power rule, this becomes the log of x to the 7th power base b, notice I'm writing my base, plus the log of y to the 3rd power base b. And now I can write this as a single logarithm. Single logarithm. Don't forget the base is b though. And so that becomes x to the 7th, y to the 3rd. Now if you want to put that in parentheses, you can. So you can say the log base b of x to the 7th, y to the 3rd. Okay? Okay, number 4. Number 4, we have the log of a base 3 minus the log of 5 base 3. Now notice the base is the same, and this is the difference of 2 logs with the same base. And notice this coefficient is a 1, and I'm subtracting, and this coefficient is a 1 right here. So right away, I can go directly to the quotient rule. There's nothing else I need to do. So I'm going to write this as a single logarithm, 1 log. Don't forget, though, the base is 3. And this is going to be, remember, this is a quotient rule you're using. So you're going to say a divided by 5. So a divided by 5. And if you want to put the argument in parentheses, it'll look like this. Log base 3. Don't forget the base. The base is 3. If you leave the base off, it's not correct. Of a divided by 5. All right, so that was number 4. Very simple. It's not that difficult. Number 5, you have the log of x plus 5 base 2 minus the log of x base 2. Okay, just to remind you what a common mistake people will make, you see this right here? And hopefully you know not to do that. What some students will do is they think that this is multiplication right here. And so when they see something like this, automatically they think of the distributive property. Well, you got to be careful. The distributive property only applies, I'm going to just write it like this, only applies with situations like this where this actually right here means product. Remember, when you read this as x times x plus 3, right? So x times x plus 3 means x squared plus 3x. This here, that's not a multiplication. That's, when you read this as the log of x plus 5 base 2. Of here does not mean to multiply. Okay, so that log is a function idea. So not an operation. This is not an operation that you're doing. You're not taking the log times, okay? So there's not multiplication. So don't say this is the log of x base 2 plus the log of 5 base 2. That's not true. All right. But notice you're going to use the quotient rule because of the division. I'm sorry, subtraction. The base is the same. So you're taking the difference of two logs of the same base. This coefficient's 1. This right here is a 1. So I can go directly to the quotient rule. And so then this becomes one logarithm. So the log of the numerator, x plus 5, divided by, and then the denominator, which is x. So the answer is the log of x plus 5 divided by x base 2. And if you want to, you can go ahead and write that in parentheses, just like this. Okay, number 6. So not that difficult, right? Very simple idea. Okay, number 6 is this. You have 7 times the natural log of x minus 3 times the natural log of y. So you're taking the difference of two logarithms with the same base. The base is e because of natural logarithm. But I cannot go directly to the quotient rule because the coefficients are not ones. So the first thing I've got to do is I have to use the power rule first. So I'm going to take the 7, I'm going to write as an exponent. I'm going to take the 3 and write as an exponent. So this becomes the natural log of x to the 7th minus the natural log of y cubed. And now I can use the quotient rule. I can write this as 1 logarithm. And so it'll be the log of x to the 7th divided by y cubed. And if you want to write it with the argument being in parentheses, that's fine. It'll look like this. Okay, so that's number 6. Number 7, you have the log of x plus the log of y minus the log of z. All right, now this time you have 3 logarithms. The first, and always go from left to right. Go from left to right. So the first thing I come across is the sum of these two logs. And notice in every situation, the coefficient is 1. And all those logs have the same base. The base is 10. So doing this one first, this becomes the log of a product. So that becomes the log of x times y base 10, right? And I'm going to rewrite this over. And now, notice I can use the quotient rule now. So I'm left with 2 logarithms, same base, difference, so quotient rule. So then this becomes the log 1. So I can write this as 1 logarithm now. So it'll be the log of xy divided by z. And if I want to write it with parentheses, that's fine as well. It'll look like this. So there's the answer. Okay, so that's number 7. Number 8, you have 2 log of x plus 3 log of y minus 7 log of z. So it's very similar to number 7, except this time you have coefficients that are not ones. So first thing I've got to do, hopefully you know this now, first thing you have to do is use the power rule. So then this becomes the log of x squared plus the log of y cubed, that's a y, minus the log of z to the 7th. And now when I go from left to right, I can do this one first. Always go from left to right. So when I go from left to right, I come across the sum of these two logs. They have the same base. Base is 10. So I can use the product rule. So this becomes the log of x squared y cubed. So that's what this is. So I wrote this as 1 logarithm minus the log of z to the 7th. And now I'm going to write this as 1 logarithm. So since that's a difference, I'm going to use the quotient rule. So it'll be the log of x squared y cubed divided by z to the 7th. And if I want to put the argument in parentheses, that's fine. So it'll be the log of x squared y cubed divided by z to the 7th. All right, so that's number 8. Okay, number 9. You have 1/3 times the log of x minus the log of 4y. Okay, so I have two logarithms, the same base, they're both base 10s. This is a subtraction, so I know I'm going to use the quotient rule. But before I can go directly to the quotient rule, notice I have the coefficient here being 1/3. So I'm going to write this as an exponent now. So this becomes the log of x to the 1/3 minus the log of 4y. Now don't expand the 4y because you're trying to condense, right? So leave it as 4y. Now I'm going to write this as using a quotient rule. So this becomes the log of x to the 1/3 divided by 4y. One thing I got to remind you of though, rewrite whenever you have an exponent that is not a positive number, rewrite it. See, this is a rational number like a fraction, right? 1/3. So you're going to remember the fact that x to the 1/3. So rational numbers, you can rewrite it using radical notation. So this becomes the cube root of x. So in other words, what you want to do is you want to rewrite this as the log of the cube root of x divided by 4y. That's how you want to write the answer. And if you want to put this argument in parentheses, you can. So it'll be the log of the cube root of x divided by 4y. Number 10. Number 10, you have the log of 2y minus the log of x plus the log of 3. All right, now again, don't expand this because you're remember the direction's set to condense, right? To condense. So you want to if you expand it, you have to go backwards again. So don't say this is the log of 2 plus the log of y. I mean it's mathematically correct, but you're making it a little bit more difficult on yourself because you're going to rewrite it back as a single logarithm. So leave it as this product. But I want you to notice that in all of these, the coefficients are 1s. So 1 times the log of 2y, subtract 1 times the log of x, plus 1 times the log of 3. And always go from left to right. So the first thing I come across is the difference of these two logarithms. Since both of those logs have the same base, I can go directly to the quotient rule. And so then I can write this as a single logarithm. It'll be 2y divided by x. So this becomes this. And then don't forget you're saying plus the log of 3. And now I'm going to use the product rule. So according to the product rule, I can write this as a single logarithm. And it'll be the log of, now here's how it's going to look. And I'm going to put this in parentheses. So it'll be the log of the product of these two arguments. So it'll be 2y divided by x times 3. See that? All right, now I do expect you to rewrite this as one fraction. So let's think about what this is right here. So let's go off to the side and think about what this part is. 2y divided by x times 3. I can write 3 as 3 divided by 1. And notice I'm going to multiply the numerators together. 2 times y times 3 is 6y. And then x times 1 is x. So this right here becomes 6y divided by x. So the answer is a log of 6y divided by x. All right, so that was it. So that is the key to the worksheet on condensing log expressions.